Hello, in this video we're going to continue studying alcohol reactions and applying that to synthesis. And here we have a molecule that we want to synthesize. We need to see what steps we need to do. So let's first identify how many carbons do we have. So 1, 2, 3, 4, 5, 6. So this compound is actually a 2-hexanol, but it's 1 bromo, that's substituent, 2-hexanol. And now with that, we can do, say if we want to start with any size of molecule, well, the easiest way to do it is having the same number of carbons and then go from there. So one molecule that I can use, then we're going to come up with a strategy with less number of carbons. But let's say that I have all of the library of compounds that I want, so I can start with something like this. But how I functionalize that and produce an alcohol. So typically in this direction, to introduce that alcohol, it would be a good idea to actually do an elimination reaction first. And so, because as it is right now, we cannot introduce the OH right now. So if I do an elimination reaction, say that I use potassium terbutoxide, and I'm choosing that because this is a bulky, so very large base. So base N, because it's bulky, it will favor the Hoffman elimination product. So terminal alkene. So having said that, and it is in fact the only alkene that we're gonna get because the leaving group is in carbon 1, 2, 3, 4, 5, and 6. So here you can get the following alkene. So once you have that alkene, what can we do to introduce that? So we cannot do hydration because that will not introduce the bromine. So that path, hydration, and in that case, it's more cognitive to have, if you had H here and OH, but that we don't do because that way we will not have what we want. If you did a hydration, you will get this in the Markovnikov case. In the anti-Markovnikov, you will get a terminal, so that's not what you want. We cannot go that path. But we can do something else. What if we think of a bromination? Remember, if you just did bromine, and we could have here, the reaction goes via bromonium, and here you will be adding a couple of bromine atoms, which might lead you to the product, but it might be tricky to get that substrate to react with something else and to do a substitution. So much efficient way to do this reaction is actually forming a halohydrine. So here, if you did this reaction, bromination, and use water as solvent, remember that here the reaction will go through a bromonium intermediate, similar to what we have in the bromination, of course. But then you will have the nucleophilic attack not by bromide, but by water in this carbon. And that will give you the desired product. So notice that what we did in the analysis, I started with the same number of carbons, but then from that alkyl halide, to introduce the other functional group, I needed to do an elimination. And once I had the elimination, hydration, Markovnikov hydration will not work because I will get only DOH and I need that group as well. Bromination only with an organic solvent such as carbon tetrachloride will give me that. Now, the idea, if you did a substitution here, you could, but you may have mixed products. But if you do this path, you will do the halohydrine formation. This is the halohydrine formation. So, and you will get here the preferred attack is when you have the bromonium is at the more substituted carbon. So you will have the attack where you want it.